do this first page, if you think about it. So what is the log base x of 1? 0. Okay. Log base x of x? 1. Okay. What about the log base x of x to the r? R. Now, my question is, why are we using x? Huh? Apply to what? Any number. You can plug in any number for x. It's a variable. So that's why x is being used there. It doesn't matter what the number is. The log base 7 of 1 is 0. The log base 7 of 7 is 1. The log base 7 of 7 raised to some power 3 is 3. Okay? What about the next one? Think about that one. X raised to the exponent log x of r. What? You asking me? It's r. Yeah. No. Does anybody, you want to put that up and show why it's r? Anybody understand why it's r? Yes, no, maybe?
No.
Want to see it?
Yes.
Okay.
What is going on back there?
We're recording.
Oh.
It's for, yeah.
You gotta wait the class in the day it's recorded. You
Huh?
gotta wait the day it was recorded.
It's for Amanda. Okay, we're in action here.
Oh. Isn't your hair covered now?
Okay, here we are. Let's run through this, all right? We said, what was this one? 0. This one? 1. This one? R. Oh, come on. R. Now this one, we said, was R as well. Isn't that what you said? All right, let's see why. So we have x raised to the log base x of r equals something. Okay? Now I'm going to take the log base x of both sides. So I'm going to take the log base x of x raised to the log base x of r equals the log base x of y. Any problem with that? Right? So now the exponent comes out front, correct? So this is the log base x of r times the log base x of x equals the log base x of y. Everybody agree with that? And what's this? 1. So the log base x of r must equal the log base x of y. Huh? What? How bad is it? If you want to go to the restroom, let us know if you have to go to the health center. All right. Now, log base x equals sign. So what do we get? R equals y, right? So there it is. Okay? So there's the math behind it. But once again, we use the variable x because it's any number. Could be any number in there, all right? How we doing? Okay.
Yeah.
What do you think the log base 2 of 7 is? You got a 2.5. How'd you come up with a 2.5? 2 cubed is 8, 2 squared is 4, so it should be a little closer to 3 instead of 2, right?
Yeah.
Okay? Everybody understand that? So you can get an idea of where the answer should be. Now, how would you evaluate this? Calculator. This is a calculator problem. Do we all know how to use the calculator?
Mhm.
Anybody have a calculator with them? What do we get as an answer? What?
2.8.
2.8, round it off. Okay? Where do you think this one's gonna be?
4 to the 4. The 4 cubed is
So like between 3 and 4, closer to a 3.
between 4 and 5.
Well, you're talking about log base 470, right?
So it's gonna be what? Yeah, there isn't.
Between 4 and 5.
Yeah, so what do you think? Give me a,
4.2.
7.
it's gotta be between 3 and 4, not greater than
Oh.
4.
Oh, 3.
No, wait, oh,
3. Oh, yeah.
oh yeah, so like 3.2,
3.7.
3.2.
3.06.
4 cubed is 64.
Oh, wait. 3.3.
Closer to 3.
Plug it in, what do you get?
3.06.
What is it?
3.06.
26?
06.
06. Okay, so you can get an idea. How about that one? What do you think? Radical 3 times radical 3 is? Radical 3 times radical 3 is? 3 times 3. So that's 3 to the 4th. Or that's radical 3 to the 4th gives you 9. So what do you think? It's got to be pretty close to 5, right? What'd you get?
Oh, it's 4.5.
It's 4.5?
Yeah.
All right. Okay? So the idea is you can approximate an answer, so when you put it in your calculator, you get something crazy, you must hit a wrong button. All right? Okay. Now we have to solve. Learn to solve. Again, there's different positions where that variable is. Depending on where that variable is, you will do different things. So what's the first thing we always have to do?
Move the 5 over.
You gotta isolate the term where the variable is. So what am I gonna do?
2 to the x equals 55.
Now what would you do?
Log base 2.5.
Good. Take that. X comes out in front, right? And therefore, X equals the log base 2 of 55.
Wait, can't you just look at it and then plug it in?
Get it and plug it in.
It's so much work.
What do you mean, get it and plug it in?
I mean, you know the base, and you know.
Right, I just wrote all the steps down. No, sure. you can see it right away, that's fine, but I just wrote all the steps down. Yes,
Mr. D, if you convert it, like, I don't know, I thought like when you converted it, I got like log to 55% instead of like.
yes, you can convert it, yeah, you can go from here to there, sure,
Okay. Oh, okay.
yeah.
I like it.
I just wrote all the in-between steps down. But that's what's happening, yes, convert it to logarithmic form. Okay? Try this one. Let's try this one. How you doing, Russell?
Can you divide by 12?
Of course, you have to. Isolate the term with the variable. Once you isolate the term with the variable, where is the variable? What position? Okay?
What? Also, X is 1.
Then we're going to convert to logarithmic form, right?
Wait,
Well,
what is the equals 2/3?
8/12.
4 goes into 8.
Oh. Yeah.
Okay, I just reduced it. Now we convert, since the variable is in the exponent, we're going to convert to logarithmic form, right? So the exponent equals,
The base, right? No, sorry, the exponent equals the number, right?
right? Do I agree with that? Charlene,
Yeah.
that's what you told me to do the last problem.
Yeah.
Okay.
I didn't say I had a problem with it.
No, I know, I just want to make sure you got it. I got the same answer you got. I'm the one who always makes mistakes. Okay? And then we just go about our business, right? Now, a lot of times you're going to see the book do this so that you don't get the two confused with the log. All right? Okay? And you plug it in your calculator. Now, if you plug this in your calculator here, if you plug this in your calculator here and round off, you're going to get a slightly different answer than you might see on a multiple choice. Okay? You should always try and round off at the end, right? So you should be able to plug that whole thing in your calculator. You're going to have to use whatchamacallit, parentheses, right? Okay? Be careful, because your calculator follows order of operations to the letter. All right? How we doing? How about this one? Okay? Everybody agree?
Mhm.
Try this one.
Is that ln base 8 or is it? Oh, never mind. I lied. That's a good question. 'Cause that's not how that works.
Natural log of
Yeah,
8x.
got it.
All right? Isolate. Write an exponential form. Divide by 8. These are all calculator section problems. Right? If we wanted an answer. How we doing? Ah, this is a little more interesting here. A little twist. Think of properties of logs here. Properties of logs. We're going to condense when you're adding the logs, it means you multiply the numbers, right? Now we write in exponential form. And we solve. Is it all making sense? The algebra is all the same, it's just a little different things we do with the logs. Okay? Multiple ways to do this one. There's a quick way and then a bunch of long ways. If I get an answer?
Yeah.
What do we have?
X equals 6.
What?
X equals 6.
X equals 6?
Yeah.
X equals 2.
X equals 2. We get log base 3 of 6 equals when you are adding the logs, you multiply.
Can you not just get rid of log base 3 of 3, just make it 1?
Yeah, you can do that, but that's gonna take you a little bit longer.
Oh,
Oh, wait, actually.
But now I have log base 3 equals, the only way they can be equal is if 6 equals 3x, and therefore x equals 2.
okay, so if log base 3 of 3 just said equal 1, it'll be 1 plus log base 3 of x. So it would just be log base 3 of x equals log base 3 of 6. That's how I did it. I thought you could do
Now you have a problem,
that.
right? You would have to do this. If you had a 1, what'd you do with the 1?
Oh, I just got rid of it. I thought you could do that.
Huh?
I just got rid of it because I thought you could do that.
But you can do it that way, but it's gonna be a lot more complicated. So if you do this, if you make that 1, then you have the log base 3 of x is going to equal, we'll write it this way. What is going on now? There we go. Minus 1 plus log base 3 is 6. Okay, subtract 1 from both sides.
Okay.
Now what do? You
Uh,
write it in exponential form, right?
oh, yeah.
So you're gonna get x equals 3 to the minus 1 plus log 3 is 6. So you plug that in your calculator, you should get 2.
It's a lot harder.
Huh?
It's a lot harder.
Yeah. Okay, so there's different ways of doing this. Try this. Everybody get this one? What do you got? X is 3, right? Log base 3 of 8 equals property of log. This becomes log base 3 of 2 to the x. Since everything is equal, you gotta have 2 to the x equals 8. So x is 3. Okay? So a bunch of problems like this. We'll do some on the board. There's one problem left here that is not on your sheet. Let's take a look at it. Let's see who can figure this one out. We haven't discussed this. We haven't looked at anything like this. Let's just see if we can think about it. You made a mistake which a lot of people are making. Yeah. A lot of people are making a mistake. People, what's the rule of exponents?
You can't add them together.
You add the exponents when you do what?
Multiplication.
Multiply. That's an addition sign. So you can't get,
Or use 2 squared,
right?
right?
I'm gonna give you a hint. Ready for your hint? There's your
Oh,
hint.
factor? Well, I feel like I did this completely wrong. Then.
That's all right, like
Wait,
I said,
So this involves logs, right?
it
It
will.
will? Okay, so not initially. Okay, so I try to do it.
That's why I said we haven't done anything like this.
Factor.
After it.
But it's not 5 to the school.
Oh. No, I don't understand this.
How do I get, how do I multiply 5 to what power to give me 5 to the 2x?
What?
I don't know.
How do I multiply 5 as a base to some exponent times 5 to some base as an exponent to give me 5 to the 2x? Yeah, but what's the exponent?
You have to write it out. I can't do it.
Is it 2 and x?
Huh?
Never mind,
I didn't hear you.
that's okay. I don't know.
What?
You would have to write that out. No, can you write out what the hypothetical that you just gave me?
How do you factor, what do you do to get x squared when you factor?
Take out an x.
So it's x times x, right? So how am I gonna get a 5 to the 2x power?
Factor out
5 to the 2 time and then 1 to the
factor out a
x.
2.
Factor out a 5?
No, factor out a 5. 5 to the 2x. Factor out a 5 to the x.
Does that say?
What's 5 to the x times 5 to the x?
Oh,
5 to the x squared.
5 to
No,
the 2x.
Oh,
you add exponents.
Aha. It went off now. The light has went off. Now I see. So you added it. That was a good one.
What is that?
Right?
That juice is.
Now you should be able to
Oh,
finish
yeah,
this.
okay, that makes sense.
I mean,
Sure you do. What do you do after you got factors and they're equal to 0? What do you do with the factors?
You said them each equal to 0.
You said each one equal to 0. That's right. You can do this now.
So 5
Bless
to the
you.
x equals -3, and 5 to the x equals 2. There's another cat. This was a good one.
Okay? So what do I get?
Yeah, x equals log base 5 of 3 and x equals log base 5 of 2. Right?
What he said.
That one I'll buy.
Oh, no, it's negative. Okay, he goes log base 5 of negative 3. Sorry.
What's wrong with that?
It doesn't.
Oh, can you not take, you can't take a log of a negative number.
No.
Oh, that makes sense.
Okay? You can't raise 5 to an exponent to give me a negative number. Question, question, question.
I want to say at the same time as you.
Okay?
But I didn't actually say
Got it? All right, so that was new, different, tricky.
Yeah.
Get your brain thinking. All right? Okay.
Sort of disappointing how much bigger the tripod is than the camera.
it's okay. It's pointing like right at the back of my head.
Now it's pointing right in front of me.
Yeah.
So let's go to the board. Board, work at your desk, I don't care, but let's do some problems.
Seems like an issue.
Emily, are you gonna work at your desk or at the
Yes,
board?
sir. I want to work at my desk.
Okay. All right, so let's try some problems.
Drew, stop.
Always deliver something.
Thank you.
Yeah, it's a- yeah.
Ready?
Get yourself under control. Oh, that's my bad. So you have.
I reminded you.
Okay, the square root of,
The square root.
let's try these, the square root of 6x minus 5. And then outside of the parentheses is a plus 10.
Drew.
Question equals 3.
The square root of 6x
Right.
minus 5 plus 10.
Plus
Outside.
10 is outside, equals 3. Solve it.
How is it long?
You can get there.
Nothing does at the board at least.
Do you have a game today? Here?
We'll get there.
What time is the baseball game at? Do you know? No, I just, no, I on the way back. No, I like it because it's like on the way back to my door now. So we go around the track that way, so here's like stuff. Are you pitching?
Get an answer?
Yes,
Well,
x equals 9.
What do you do?
X
Oh, wait,
equals
aren't you
9.
going first?
Everybody
It's like
agree?
a run. I was
Okay.
asking you like playing first base because you couldn't move. What's Annie playing? She's gonna be thrilled about that.
Again, these are calculator problems, so rather than punch buttons, let's just make sure we have it set up correctly, all right? So 10 to the 2x power
Oh,
plus 3 out, next to it equals 8. So don't worry about your just set it up. You don't have to push a button.
What was the setting, please?
10 to the 2x power plus 3 equals 8. We have an answer? Should be the log of 5 divided by 2. X equals log of 5 divided by 2.
to me it makes sense.
So you're about to sneak.
Oh,
You're just
no.
making it.
You're solving correct, right?
Wait, but it's 10 to the 2, so we're doing log base 10.
Log base 10, that's what I said, log of 5.
Log base 10 to x equals 5. Where did the x go? Oh, it's up 2 to the x, not to the
Move.
Okay? Yes? All right, how about this one? 3 raised to the 0.1x power. 3 raised to the 0.1x power minus 4. Minus 4 is outside there. Equals 5. And you should be able to give me an exact answer without a calculator. And that's also what I should do is.
Yeah.
Huh?
Yeah, I got the point of x equals 2 divided by 0.1.
Yeah, great, that is too.
You can't do that without a calculator?
No, I'm sorry. That's really good.
Oh, is it, wait. Is it 20? Yeah, it's 20, yeah.
Oh,
Multiplied by
Yeah,
10,
that's
to-
right.
you know, 10 times 0.1 gives you 1. So 2 times 10 is 20. All right, good, okay. Let's move on to other kinds.
That's much.
Here we go. The natural log of x plus the natural log of parentheses x minus 2.
it was, and I thought it was.
The natural log of x plus the natural log parentheses x minus 2
Close parentheses.
equals 1.
Okay.
Yes.
I don't know. I did, but I don't know.
This is a tricky one.
I think I got it.
This is a tricky one. When you add logs, what do?
You multiply them. Oh, I didn't do that.
Huh? Well, then what do?
You move the ln
Well, I
over to
moved
make
the
it e.
2. I moved the 2 from, I ended up with 2 log,
I-
2 natural log of it.
Take the natural log of each side, so like.
So no, now you write it in exponential form.
Oh. and
Right?
we're
Oh.
not sure it's to the factor one.
Equals what?
E. Yeah, E, right?
What?
E to the 1.
No, well,
Ah, e to the 1 is e, right?
Yeah, but on the calculator, you can't just put in E, you have to put E to the 1.
I have that too, but I did it a different way. I had it just.
This is really ugly. Why is that like that?
I never factored it. I kept it factored, so I had it as x still as x to these two.
So then you just take a
That's really ugly.
log of both sides.
Ew.
I
Can
never,
you leave it there?
yeah, I kept it on like unfactored.
That's fine.
I think the book made a mistake.
So what is actually?
I think the book made a mistake. And
Again,
when I looked at this, and when I looked at the answer, this is an ugly one.
Do you have to factor
Because
it?
now you gotta,
Can you keep it unfactored? Just keep it as x times x minus 2 equals e?
do what?
Well, then I did like, I divided by x, so it's e divided by x equals x minus 2. Can you do that?
Yeah, but you still have x's on both sides of the equation,
Oh, yeah.
right?
That's
I
not
mean,
good.
this is a quadratic.
Oh,
I'm sorry, this is an ugly one.
Wait, this is a quadratic with E?
Yeah, that's why, I don't know, I think the book made a mistake.
I'm set, thanks.
If you were to do that, let's just take a look, since we're here. Right? You can't factor that, what would you use?
The quadratic formula.
Quadratic formula, and rather than go through the quadratic formula, let's look at b squared minus, let's look at b squared minus 4ac, which is the determinant. So what is b squared minus 4ac here? B squared is 4 minus 4 times 1 times a negative e. So the book's wrong. Because that gives me a positive number, I can take the square root, there's 2 positive roots. So I looked at the answer in the book and I chose the problem, and it's not good. All right, let's try this one. This one should work. Last one, log base 5. Log base 5, 2x plus 15 equals log base 5 of 3x.
Log base 5 of x to the 15.
Yes,
And the second one was log base 5 of 3x, right?
yes. How do I delete this thing? Here. No. How do I get rid of that? I'll worry about it later. What is it? Log base 5, right? 2x plus 15. What's your answer?
15.
Should have it done right away.
Yeah, but
15.
Huh?
15.
what you said.
15.
Yeah.
The log is log base 5, base 5. The only way they can be equal is if 2x plus 15 equals 3x. So 15 equals x. Okay? Practice, practice, practice. Your homework is on Canvas. You'll notice we have another quiz on Friday. Okay?
Mr. E,
Yeah.
I just got a schedule change in the middle of that class period. So I'm in your bebop class now, so what should I do?
You're
'Cause-
moving to B period?
Yeah.
Garcia.
When?
Well, I just got it today during the middle of that class.
So I guess you have to go math class.
You should probably come to that last period then. Because they're a period ahead of you.
Oh, they are? Oh,
Yeah,
okay.
because we had class, we did this yesterday.
Okay, so we're looking at today.
So so you should probably come.
Well, I'll see you guys later today.
Yo, that's
Alright.
sad, bro.
You're ready. Russell, you doing all right?
Yeah, I'm good.
She's really sad.
Do you see Harry?
Yeah.
And do you see
I would
Finder?
never. I don't know this, I'm a loyal fan.
See you later.